Earth is an abundant source of material. The air we breathe, the water we drink, stones, rocks, almost everything that is around us is useful for some purpose or the other. Most of these materials are the compounds of some or the other elements, while some of the substances are found in their elemental form. For convenience, these elements have been classified into metals, nonmetals, and metalloids. Metalloids are the elements which possess both the properties of metals as well as nonmetals. Example: silicon, germanium, antimony, etc. Whereas metals and nonmetals are classified distinctly by their physical and chemical properties. Let us look at one activity. Take sample pieces of copper, iron, aluminium, charcoal, sulfur powder, pencil lead, that is graphite. Identify and classify the above samples as metals and nonmetals. Copper, iron, and aluminium are metals. Charcoal, sulfur powder, and pencil lead, that is graphite, are nonmetals. Which features did you consider to classify them? Hardness, luster, sonorous, that ringing sound when struck. Metals are hard, they shine, and are sonorous. Nonmetals are brittle, they look dull, and are not sonorous. Now let us move to the physical properties of metals. Physical state. Metals are solids at room temperature, with exception of mercury and gallium, which are in liquid form at room temperature. Let us perform an activity. Take samples of metals like iron, copper, aluminium, and magnesium. Note the appearance of each sample. We find that all metals shine in natural state. Clean the surface of each sample with sandpaper and note their appearance again. When polished, it has a reflecting surface. It is a luster. Metals in their pure state have a shine and can be polished to give a highly reflective surface. Again, activity time. Take a lid of a cold drink bottle, a coin, a thick aluminium wire. Strike it with a hammer several times. What do you observe? Record the change in shapes of the metals. All things become flat like a sheet. This property is called as malleability. You will find that metals have the ability to withstand hammering and can be made into thin sheets. Students, you all must have seen your mother's sari with a zari border. Observe the zari borders of pure silk saris. Do you know what this zari is made up of? And why do you think intricate designs with zari can be woven in a sari? Zari is made from silver and gold drawn into thread. These threads help in making intricate designs. Students, take an electric wire. Remove the insulation of an electric wire. What do you observe? We can see the copper wire inside the insulation. The ability of metals to be drawn into thin wires is called ductility. Gold and silver are the most ductile metals. You will be surprised to know that 1 gram of gold can be drawn into a wire of 2 kilometers length. Students, name some metals that are used for making cooking vessels. Iron, aluminium, copper, and stainless steel are some metals that are used for making cooking vessels. Do you know why only these metals are used for making cooking vessels? All these metals are good conductors of heat. Let us look at another activity. Take an aluminium or copper wire. Clamp this wire on a stand as shown in the figure. Keep a wedge of butter on the free end of the wire. Heat the wire with a spirit lamp or a burner near the place where it is clamped. Does the metal wire melt? No. Note your observations. The butter starts melting after some time. From this, we can say that metals are good conductors of heat and have high melting points. Silver and copper are the best conductors of heat, whereas lead and mercury are the poor conductors of heat. Let us perform one activity before moving to the next property. Set up an electrical circuit as shown. Place the metal to be tested in the circuit between the terminals. Does the bulb glow? Yes. What does this indicate? It indicates that aluminium is a good conductor of electricity. Now look at this electric wire. What is the inside and outside material of an electric wire? Copper wire is inside. It is covered with PVC, that is, polyvinyl chloride. This shows that metals are good conductors of electricity. Electric wires are made of copper having an outer coating of PVC, that is polyvinyl chloride, since PVC is a bad conductor of electricity. Let us understand the next property through this activity. Take samples of iron nail, thick copper and aluminium wire and magnesium ribbon. Take a piece of sodium metal in a watch glass. Students, handle sodium metal carefully. Try to cut these samples with a sharp knife and note your observations. All metals cannot be cut with a knife. Since sodium is a soft metal, it can be cut easily with a knife. This shows that metals are generally hard and the hardness differs from metal to metal. Alkali metals like sodium and potassium are soft metals and can be cut easily with a knife. Let us study about another property, that is melting point and boiling point. Metals usually have high melting and boiling point. Tungsten has the highest melting point, whereas sodium and potassium have low melting points. Students, have you ever thought why the bells in your schools, temples and churches are made of metals? Metals are sonorous, so they are used in making bells. Sonorous means the metals which can produce a sound on striking a hard surface. Let us perform this activity before moving to the physical properties of non-metals. Take the samples of coal, graphite, sulfur, iodine and bromine. We will note the physical properties like physical state, luster, malleability, ductility, conduction of heat, conduction of electricity, melting point and boiling point, sonorous of these non-metals. Physical state. Coal, graphite, sulfur, iodine are solid and bromine is in liquid state. Luster. Coal, graphite, sulfur, iodine don't shine. Only bromine has luster. Malleability and ductility. They are neither malleable nor ductile. Conduction of heat and electricity. Graphite is a good conductor of heat and electricity. Other non-metals are bad conductors of heat and electricity. All of them have low melting and boiling points. All of them are not sonorous. Let us look at the physical properties of non-metals. Non-metals are either in solid or gaseous state, with the exception of bromine, which is in liquid state. Non-metals usually do not have luster, except iodine and diamond, which is an allotrope of carbon and the most lustrous of all the substances. Non-metals do not possess the property of hardness except carbon in the form of diamond, which is the hardest substance known. Diamond also has a high melting and boiling point. Non-metals do not conduct electricity except graphite, which is an allotrope of carbon. Since there are exceptions in each of the physical properties, elements can be classified more clearly as metals and non-metals on the basis of their chemical properties. Now let us move on to the chemical properties of metals. To learn about the chemical properties of metals, take samples of aluminium, copper, iron, lead, magnesium, zinc and sodium to do this activity. Hold any of the samples taken above with a pair of tongs and burn over a flame. Repeat with the other metal samples except sodium. Hold samples with a pair of tongs and burn over a flame. Collect the product formed. Let the product and the metal surface cool down. Which metals burn easily? Sodium burns in air. Magnesium burns on heating. Aluminium, copper, iron, lead and zinc do not burn easily.